the actual displacement. So here's what I'm going to do. I'm going to go x, y. So what I'm going to do is I'm going to take all of the horizontal components right here and put them on x. So I have 50 kilometers west and 24.749 kilometers east. So I put that here, 24.749 kilometers east, and 50 kilometers to the west. Okay? Then I'm going to go back and I'm going to do my north-south components. So I have 60 kilometers south. And 24.749 kilometers to the north. Okay? So by adding all of my components together, I can come up with a net triangle. Meaning, I can have a second triangle, or a third triangle, whatever it is in this question. I can have another triangle that will actually calculate the displacement for me. So I'm going to add these together right now. Okay, so I'm going to add them together. Now, what's the problem that I have here? Are they all in the same direction? No. So I have to figure something out here. So one way I could do it is I can make my west and my north, or my west and my south, I can make them negatives and add them. But we're a pretty smart group here, so I'm going to figure this out. Which way, when I add those together, are you going to end up going? West. So 50 subtract 24.749, and that's going to be in the west direction. So what is that? 251 kilometers, and that's going to be west. Agreed? And then 60 subtract 24.749, so that would be 35.251 kilometers. And which one is it going to go? South. Okay. So I've now got what we call the net components of this. And net means I add and subtract to get my net total. In this case, I've got a west and a south. Once I've got it narrowed down to those two, I can now draw a right triangle and solve for my displacement. So I'm going to draw my right triangle right here. Going south, so that's 35.251. And then I'm going to go west, 25.251 kilometers west. And I want that guy and this angle, and I'll have solved where my total displacement was for that police cruiser. Okay? So all I got to do now is I have to use Pythagoras' theorem. So let's find out what that displacement is right here. Forty-three point 361 kilometers. Now I need my direction. So I've got to find my direction. So tan of 25.251 divided by 35.251.
So 35.6 degrees west.
Solve 35.6 degrees west. Perfect. Thanks. Okay. So what I've just done is I found this right here. And I did it using the components of the individual vectors. Now, the reason I do the question this other way. Now I could have done it this way, and I would have ended up getting the same answer. Because this triangle right here is that triangle right there. It's the same triangle. I could have done it that way. But when I start using subtraction of vectors, I like using my components method. Because then I just have to put a negative in there and then change the sign of it. And it makes it a lot easier for you to do it. Okay? So then to find my average velocity, I divide that by the total time. What was the total time in the question? 1.3 hours. And that would give me my average velocity for this question. Okay?
So how do you know where to take your angle?
You draw two vectors that are connecting, right?
Yeah.
So where's the start of the first one?
So you just wrote, so if I put my west as my first vector.
Okay. So if Lexi put her west as her first vector, that would be this. And then she has to connect it to the south, which gives you that. So you would get that right there, Lex.
Okay. So
Right? So what is that angle going to end up being? The complement of that one right there.
Yeah.
You take 90 degrees, subtract that angle, and that's what that angle is. So it doesn't matter if you draw it west then south or south then west. You're going to get the same answer. Okay? All right? Yeah.
You also do it during like trig ratios and stuff like that.
Trig ratios.
Like trig things like kind of just figuring out like solving two parallel lines and like that. I guess they wouldn't even be parallel, but like just like finding solving that triangle and then using it to solve that triangle. Makes sense.
Say that.
Oh, I'll just be quiet.
But Brendan, when you get a list of 6 different things in six different directions, you won't be able to do that.
Yeah. Or even 3 for that matter, if all 3 of them, if only one of them is on a horizontal or vertical. It makes it a lot more difficult. Okay? All right. I did a question for you the other day I want you to take a look at, so flip your page over. I'm going to do it again. Plane's velocity changes from 200 kilometers an hour north to 300 kilometers an hour north, 30 degrees west. Find the change in velocity. Okay. Very first thing I'm going to do is write the change in velocity at the top of my page. And it is V2 minus V1. Okay, now that seems simple enough, but what it is I don't put the numbers in there. And I know for sure that one of you is going to do that on the test. Because you don't listen well enough. Don't put the numbers in there. It's just a guide to show you how to draw the vectors properly. But somebody always does it. They always just put the numbers in. Okay? Can't do that. So now what I do is I draw my 2 individual vectors first. So the first one is 200 kilometers an hour to the north. Vector 2 is 300 kilometers an hour north, 30 degrees to the west. Like that. Okay? So it wants to find the change in velocity. So what I need to do, again, I'm going to draw it out first so that you can see the visual, but I'm going to approach the question and solve it a different method. Okay, so the first thing I would do then is I draw out V2, because that's what my equation says to do. If I want to find my change in velocity, I have to take the V2 first, and then I have to take the negative V1. So I draw my vector as such. that being 30 degrees right there. Okay? Then I need the negative 200 kilometers an hour to the north. So I put it to the south. So it's going to be somewhere down here. So that's 200 kilometers an hour. And that is south. Now, this presents a different scenario than you have seen up to date. So far, all we have worked with is right angle triangles. I don't have a right angle triangle here now. So what does that bring into play then? What are the methods that I use to solve for this? If I were to just work on this triangle, I need to use either the law of sines or the law of cosines. All of you have done and worked with the law of sines and cosines. You can use that method if you'd like. Alright? But I'm going to use the same method I just used with the table before. So the first thing I need to do is I need to find out the components of this guy right here. Okay? So the sine of 30 degrees. 0.5 times 300, 150 kilometers an hour. And that is west. Okay? So now I need the cos of 30 times 300. 808. And that's to the north, right? Okay. So now, let's go over here. If you don't like the law of sines and the law of cosines, you can still solve this using just right angle trig. And that's by setting this chart up. If you like the law of sines and the law of cosines, you can use that as well. That's okay. Alright, so first things first. My horizontals, I only have one, 150 kilometers an hour to the west. My vertical, I'm going to start with that guy, 259.808 to the north. And now, 200 kilometers an hour. In what direction? I have to change this to south because I'm subtracting that. So I go over here and I put it in here as 200 kilometers an hour. South. Again, I want to find my net. So I have 150 west. I have 59.808 in what direction? North. That's not degrees, jerk. So now I can draw a right triangle and solve this whole question using a right triangle. So I want to go 150 to the west. And I'm going to go 59.808 to the north. And I'm looking for this guy right here, which is that guy right there. This is you changing velocity right here.
Yeah, but if you're trying to find the angle, you would use that one, right?
Okay, so again, you just use the Pythagoras' theorem. 150 squared plus 59.808 squared. What do we get? .484 kilometers an hour. And what's the angle? Calculate the angle now. Second function tan, 59.808 over 150. No. That's right. You do it.
I got 21.738.
Okay?
So my question is though, is that, when are you gonna know to subtract it off 90? And when are you,
You don't have to.
you never do?
No.
Cause like,
No, if you draw it the other direction, I'll accept that too.
okay,
You can do it either or. So, hypothetically, to answer your question, is if you drew this, and this, and got that,
yeah,
that's okay.
okay.
Yeah, you don't have to change it. Alright? So, any questions about the chart? So all I'm doing is I draw my individual vectors, and then I write the components on the chart, and I make myself one last right triangle. Okay? Now, I will go back, and I'm going to solve this for those of you that like the law of sines and the law of cosines. I'm okay with that. Using parallel lines, that means that this is 30 degrees right here. So I've got the law of cosines that needs to solve for this right here, which would be your change in velocity. Now it's just as easy to do this, but finding angles is the part that causes the problem. Okay? So let's do this right now. So, law of cosines, square root, 200 squared plus 300 squared minus 2 times 200 times 300 times the cos of 30. So I'll write that, I'm just going to write that on the next board here. Run over. So, to find my change in velocity, the law of cosines, 200 squared plus 300 squared minus 2 times 200 times 300 times the cos of 30 degrees. And what is it?
161.484.
161.484 kilometers per hour, right? Let's just check. What do I got there? Yeah. So we got the exact same thing. So now I have to find an angle. This is where it becomes a little bit more difficult. I need that angle right there. So now, again, I don't have right angled trig. So I need to use my law of sines. So the sine of alpha, I'm just going to write that down here, sine alpha over 200 is equal to the sine of 30 over 161.484. All right, so punch that into your calculator. Punch it in, Seth.
38.262.
38 point.
262.
Yeah. All right. I want everybody to watch this for a second, please. I need to describe that angle. I need to describe that angle. So, realistically, that angle here is 38.262, and this part is 30. So, to describe that angle, I need to describe it using that. So, how would I write that angle out from here all the way around to there? How would I write it out? No.
68.
Yeah, well, what's the first direction you're going?
Oh, it'd be over.
North. Yep, you're right.
68.
Yes.
0.262.
68.262 degrees west. That's the entire angle. That's why when you do this method, it's sometimes more errors are made using that method than right triangle trig. But you can do it. Now, is that the same angle I got earlier? It would have been had I used that as an angle. I use this as my angle, so it was the complement of it. Okay? All right? Two methods to do this. Whatever method you're most confident with, you use. I do not check it. If you like right triangle trig, then just use triangle trig using your components. If you like using law of cosines and law of sines and you're good with it, grade 11s, we just finished doing that, you should be okay with that. You can do either one. Like I said, it's just the angles that will cause you to have errors. Alright? That's all I have for today. So in this package that I handed out, of the one I just did with the, you can continue with question 2 and 3 on the front side and 3 and 4. All the practice questions that I put in here are all questions that you need to have done.
For one.
So we've got to get it done. Alright? Okay, we have all day today to now work on that.